Our universe might be dying only to be born again. Everything you see, including yourself, is made from ancient cosmic debris, forged in stellar explosions that occurred long before our sun even existed. Carl Sagan famously said the cosmos is within us, that we are made of star stuff, and this reveals a breathtaking truth. The universe operates through an endless cycle of creation and collapse, a magnificent recycling process where endings are merely new beginnings. By the end of this journey, you will understand how the universe recycles itself, uncovering your own profound connection to this eternal cosmic dance. We will explore strange evidence in the ancient light of creation and investigate whether black holes could be cosmic memory banks. How does it feel to know you are part of something that never truly ends? That ancient stardust within us hints at a universe far more cyclical than we ever realized. This grand cosmic recycling operates on a scale almost impossible to comprehend. A phoenix rising from its own ashes not once, but endlessly. Ancient Hindu scriptures spoke of kalpas, vast cycles of creation and dissolution lasting billions of years. Modern theoretical physics now echoes this profound intuition, suggesting our universe is not a one-time event but one chapter in an infinite series. The brilliant physicist Roger Penrose proposed a model called Conformal Cyclic Cosmology. In this mind-bending vision, the distant, empty future of our universe, after all matter has decayed, becomes mathematically identical to the hot, dense beginning of the next. The end is not a final period but a seamless transition into a new genesis. These are not mere identical repetitions, like a film reel playing the same movie again and again. Each cycle is an evolutionary step. The universe, in a sense, learns from itself. With each new beginning, the fundamental constants or the arrangement of matter might be slightly different, potentially allowing for more complex structures, perhaps even new forms of life and consciousness to emerge. This shatters our everyday perception of time as a straight line with a definite start and finish. It suggests that consciousness itself, the very awareness that allows us to ponder these mysteries, could be an intrinsic part of this eternal recycling process. But this raises a monumental question. If the universe resets, how could anything carry over? How could information, the blueprint of what was, possibly survive the fiery end of all things? The answer might lie in the most enigmatic vaults in existence, black holes. This ancient light, a whisper from the dawn of time, is our first tangible piece of evidence. The cosmic microwave background radiation is a faint, cold glow that fills every cubic inch of the cosmos. It is the remnant heat from the Big Bang, cooled and stretched over billions of years into invisible microwaves. Think of it as the universe's first photograph, taken when it was just a newborn. But this picture is not perfectly smooth. It is covered in tiny, mottled patterns of hot and cold spots, like a cosmic fingerprint. For decades, scientists assumed these patterns were random, the natural result of quantum fluctuations in the infant universe. Yet, as our observations grew more precise, strange anomalies began to appear. Some of these cold spots are far larger and colder than our standard models can explain. It is as if you found a perfectly round, frozen lake in the middle of a vast, gently rolling desert. How could such a feature form? One compelling theory suggests these are cosmic bruises, imprints from a titanic collision with another universe in the vast multiverse. Another, even more profound idea is that they are echoes. When astronomers with the Planck Space Telescope analyzed the data, they also found curious concentric rings within this background radiation. These are not rings you could see with your eyes, but patterns revealed through sophisticated statistical analysis. Imagine throwing a stone into a pond. The ripples expand outward, and if you could freeze the pond's surface, you would see a perfect record of that event. These rings in the cosmic microwave background could be the frozen ripples from a cataclysmic event that occurred before our Big Bang. What event could possibly create ripples that cross the boundary between universes, the collision of supermassive black holes in a previous cosmic cycle? Their final, violent merger would have sent shockwaves of gravitational energy through the fabric of reality, leaving a faint, circular scar on the very first light of the next universe. This means we might be looking at a fossil, a direct imprint from a universe that died long before our own was born. The information encoded in that ancient collision, carried by gravitational waves, was somehow preserved through the fiery end of one cosmos and the blazing beginning of the next. If these rings are indeed real, they are a form of cosmic memory written in the sky. They challenge our most fundamental understanding of time, suggesting that the arrow of time we experience may not be absolute. What other messages from our cosmic ancestors are hidden in this primordial light, waiting for us to learn how to read them? Black holes present us with the ultimate cosmic contradiction. They appear to be the universe's final endpoints, monstrous voids from which nothing, not even light, can escape. Yet they might also be its most sophisticated recycling plants, and the key to this paradox lies in a fundamental question about information itself. What happens to the blueprint of a star or a planet or a person when it falls into a black hole? According to the rules of quantum mechanics, information can never be truly destroyed. It might be scrambled beyond recognition, but it must, in principle, be recoverable. Stephen Hawking's groundbreaking work revealed a terrifying problem. He showed that black holes slowly evaporate over astronomical timescales, emitting a faint whisper of radiation. But this Hawking radiation, he argued, was purely thermal and random. It contained no information about what fell in. If a black hole evaporates completely, all the information it ever consumed would vanish from reality forever, violating a core law of physics. This is the black hole information paradox, a crisis that has haunted theoretical physics for decades. The resolution to this paradox might be the very mechanism that allows the cosmos to remember itself. New ideas from the holographic principle and string theory suggest a breathtaking solution. The information is not lost inside the black hole's crushing depths. Instead, it is meticulously encoded, pixel by pixel, onto the black hole's two-dimensional surface, the event horizon. Imagine the event horizon not as a simple boundary, but as a cosmic hard drive. Every bit of information about every atom that crosses it is stored there, imprinted like a hologram. Then, as the black hole emits its Hawking radiation over eons, that radiation is not random noise. It carries away subtle, encoded messages, slowly leaking the stored information back out into the universe. The black hole does not destroy, it transforms and eventually returns what it consumed. This transforms these celestial monsters from agents of ultimate destruction into potential custodians of cosmic memory. They are not endpoints but temporary vaults, safeguarding the universe's data through the most violent transitions. This idea reaches its most profound conclusion with a radical theory about the supermassive black holes that anchor the centers of galaxies. Some physicists propose that within the heart of a black hole, where our laws of physics break down, the fabric of spacetime does not simply end in a singularity. Instead, it may give birth to an entirely new universe, expanding into its own dimensions. In this view, our entire cosmos could have been born from a black hole in a parent universe. The information encoded on that parent black hole's event horizon would then become the seed, the initial conditions, for the new universe it spawned. The supermassive black holes we observe today might not be graves but cosmic wombs, the engines of an endless cycle of rebirth. The information they preserve, the total history of a universe, becomes the genetic code for the next. How could the specific arrangement of a galaxy or the memory of a supernova in one cycle influence the physics of the next? This is the deepest mystery of cosmic recycling, a process that suggests reality itself is a continuous self-learning loop written in the indelible language of information. Dark energy is the silent, dominant force shaping our cosmic destiny. It makes up a staggering 68% of everything in the universe, a mysterious pressure woven into the fabric of empty space itself. Its existence was confirmed when astronomers studying distant supernovas made a shocking discovery. The universe is not just expanding, it is accelerating, flying apart faster and faster with every passing moment. This was a revelation that overturned centuries of assumed knowledge. We always thought gravity would eventually slow the cosmic expansion, perhaps even pull everything back together. Instead, an unseen repulsive force is winning the tug of war. This force, dark energy, seems to be writing the final chapter of our universe, leading to an eternal, cold, and empty dispersion. Yet within this seemingly final act, cyclic cosmology finds its most compelling modern evidence. What if dark energy is not a death sentence, but a vital part of the cosmic recycling machinery? The key lies in its potential behavior over time. Some leading theories suggest that the density of dark energy is not constant. It could be slowly weakening, decaying away over trillions of years. If this is true, then the current era of acceleration is just a phase. Eventually, the relentless pull of gravity, primarily from the other great mystery, dark matter, could regain the upper hand. The great cosmic expansion would slow, halt, and then reverse. Imagine a ball thrown high into the air. It slows at the apex of its flight, seemingly suspended for a moment before gravity pulls it back down. Our entire cosmos could be that ball, with dark energy providing the initial throw and gravity ensuring its return. This intricate dance between dark energy and dark matter, between repulsion and attraction, could be the very engine that powers the cycle. It would be the cosmic lung, inhaling to create a new universe and exhaling to reset it. Missions like the Dark Energy Survey and the upcoming Euclid Space Telescope are now meticulously measuring the properties of dark energy, searching for any hint that it changes over time. They are trying to read the equation of state for this phantom, to learn if the universe's fate is a one-way trip to silence or a temporary separation before a great return. The answer will determine whether we live in a universe that truly ends or one that is merely resting between breaths. The second law of thermodynamics presents the single greatest obstacle to an endless cosmos. It dictates a one-way street, a universe where disorder or entropy must always increase. This is the source of the arrow of time we feel every day, the reason an ice cube melts in warm water but never spontaneously reforms from the pool. It suggests the cosmos is a clock, slowly and irrevocably winding down toward a final state of maximum disorder known as heat death, a cold, dark, and uniform graveyard. For a cyclic universe to be possible, this clock must somehow be rewound. How can entropy be reset without violating one of physics's most sacred laws? Roger Penrose's radical vision offers one answer. He proposes that in the unimaginably distant future, when all matter has decayed into light and other massless particles, the concept of scale becomes meaningless. In this conformal geometry, a single photon and the entire vast, empty universe are mathematically identical. With no massive particles left to create disorder, entropy effectively resets to zero. The end of time becomes a blank slate, indistinguishable from the smooth, low-entropy beginning of the next cycle. Other theories look to the quantum realm or to higher dimensions for a solution. In brainworld scenarios where our universe is a three-dimensional membrane floating in a higher dimensional bulk, a collision with a neighboring brain could inject immense energy, scrubbing the slate clean and starting a new hot Big Bang. The heat death of our universe would then be merely a quiet period before the next cosmic collision. The key to all these models is information. If information is truly preserved, as the resolution to the black hole paradox suggests, then perhaps the universe does not need to reset its entropy completely. Instead, the information could serve as a template. The organized data from the previous cycle could guide the formation of the next, allowing for a natural decrease in entropy in the new universe's early moments because the blueprint for order already exists. It would be like shaking a box of scattered puzzle pieces and having them land not in a random heap but perfectly assembled into the picture. The universe performs this apparent magic trick by never truly losing the instructions. This transforms our understanding of cosmic endings. The heat death may not be a final oblivion, but a necessary period of rest and recalibration, a deep cosmic breath held before the next great expansion. What strange, yet to be discovered physics governs this ultimate recycling process, ensuring that the story never truly ends, but is forever retold with infinite variation. Deep within the fabric of empty space, a seething ocean of potential energy churns. This is the quantum vacuum, a realm where the concept of nothingness is a myth. Here, virtual particles and their antiparticles constantly flicker into existence, borrowing energy from the void for a fleeting moment before annihilating each other and vanishing. This quantum foam is not just a theoretical curiosity. It is the engine of creation, and it might be the very mechanism that powers the cosmic cycle. The same quantum fluctuations that seeded the galaxies in our own universe could be the persistent memory that carries through from one cycle to the next. Our entire cosmic story, from the grandest galaxy cluster to the smallest planet, may have begun as a microscopic ripple in this quantum sea. How can something so infinitesimally small dictate the fate of the entire cosmos? The answer lies in a process called inflation. In the first fraction of a second after the Big Bang, a patch of this quantum foam underwent a violent, exponential expansion, stretching those tiny, random fluctuations into the vast seeds of cosmic structure. The hot and cold spots in the cosmic microwave background are the amplified echoes of that primordial quantum noise. In a cyclic universe, this process does not happen just once. Each new cycle could inherit a slightly modified version of this quantum blueprint from its predecessor. The information encoded on a parent black hole's surface, for instance, could manifest as a new pattern of quantum fluctuations in the newborn universe, gently guiding the formation of its galaxies and stars. This offers a potential solution to one of physics's greatest puzzles, the cosmological constant problem. We observe that the energy of the vacuum is incredibly small, yet our theories predict it should be astronomically larger. Why is the force of empty space so weak? In a cyclic cosmos, the value of this vacuum energy is not a fixed constant. It could be reset with each new cycle, a dial that is randomly turned to a new setting every time the universe is reborn. We simply live in a cycle where the number happened to be just right for galaxies, stars, and life to form. Some theories propose an even more direct role for the quantum vacuum in cosmic rebirth. Our current vacuum state might not be the most stable one. It could be a false vacuum teetering on the edge of a more fundamental state. A rare quantum event, a process called vacuum decay, could trigger a bubble of true vacuum to nucleate somewhere in space. This bubble would then expand at the speed of light, its walls rewriting the laws of physics as they pass, effectively giving birth to a new universe with entirely different properties within the old one. The quantum realm and the cosmic scale are not separate domains. They are deeply intertwined, two sides of the same coin. At the unimaginably small Planck scale, where gravity and quantum mechanics must finally unite, the barrier between cosmic cycles might become permeable. The fundamental pixels of spacetime itself could facilitate the transfer of information, ensuring that the story never truly ends but is perpetually rewritten. The universe learns and evolves because its most basic ingredients remember. Our universe's dramatic birth might not have been a beginning at all, but a transformation. The moment we call the Big Bang could be a cosmic phase transition, similar to water freezing into ice. The immense heat and density were not born from nothing, but were the result of a previous state of the cosmos undergoing a fundamental shift. In this cyclic view, the initial singularity described by the Standard Model is not the ultimate starting line. It is a turning point, a moment of rebound from a prior era of contraction. The entire cosmos may have collapsed in on itself, reaching an incredible density before bouncing outward in the event we now call the Big Bang. This bounce avoids the perplexing problem of a singularity, a point of infinite density where our known laws of physics simply break down and cease to provide answers. One of the most compelling models for this is the Ekpyrotic universe. It envisions our reality as a three-dimensional membrane or brain existing within a higher dimensional space. In this vast cosmic ocean, our brain could have collided with a neighboring one. That collision would have been unimaginably violent, converting the sheer kinetic energy of the impact directly into the seething, hot soup of particles and radiation that characterized our universe's first moments. This elegant idea also provides a natural explanation for one of the cosmos's great mysteries, its overall uniformity. The temperature of the cosmic microwave background is strikingly even across the sky, a fact that requires explanation. The Ekpyrotic model suggests that the pre-Bang universe was stretched and smoothed during a long, slow contraction, naturally ironing out any wrinkles and creating the homogeneous cosmos we observe. Of course, the precise mechanics of this cosmic bounce involve the deepest frontiers of physics, like string theory and the elusive theory of quantum gravity. These frameworks attempt to describe how spacetime itself behaves under such extreme conditions, potentially allowing for a seamless transition from contraction to expansion. How could we ever find evidence for such an event? The answer might be written in the sky. The titanic collision of brains or the dynamics of the bounce itself would have sent powerful ripples through spacetime, known as primordial gravitational waves. Future observatories might detect the unique fingerprint of these waves, a specific pattern distinct from those created by colliding black holes. Alternatively, subtle, unexplained anomalies in the cosmic microwave background could be the scars left by this primordial event. Was our universe's birth actually a rebirth from a previous cosmic era? This perspective completely transforms our understanding of cosmic origins and destiny, suggesting that every ending carries within it the seed of a new beginning, written into the fundamental fabric of reality. Roger Penrose's vision of the cosmos is one of breathtaking elegance and profound simplicity. In his model of conformal cyclic cosmology, the universe avoids a final, silent death by transforming its own end into a new beginning. Picture an infinity symbol drawn on the scale of reality itself, each loop representing an eon, a universe lasting trillions upon trillions of years. As our own cosmos expands toward an unimaginably distant future, all massive particles, from stars to the last protons, eventually decay into pure, massless energy. When only light and gravitational waves remain, the very concept of distance and size loses all meaning. A single photon and the entire vast, empty cosmos become mathematically identical through a transformation called conformal rescaling. The infinite future and the zero-sized beginning smoothly merge into one. This is not a violent collapse, but a quiet, seamless transition where the final state of one universe becomes the hot, dense singularity of the next. The Big Bang was not the absolute beginning of everything, but a phase change in an endless sequence. One of the most beautiful aspects of this model is how it resolves the entropy problem. The second law of thermodynamics dictates that disorder must increase, seemingly making cyclic rebirth impossible. But in a universe dominated solely by radiation, there is no inherent scale for entropy. The maximum disorder at the end of one cycle becomes the minimum disorder at the start of the next, resetting the cosmic clock without violating any physical laws. The evidence for this radical idea might be written in the oldest light we can see. Penrose and his colleagues have identified strange, concentric rings within the cosmic microwave background, patterns of temperature variation that are difficult to explain with standard cosmology. These rings could be the imprints of truly colossal events from a previous eon, the gravitational shockwaves produced when supermassive black holes collided in a universe that existed before our own. Each ring is a fossilized echo, a ripple that crossed the boundary between cosmic cycles. If this is true, then we are not just looking at the afterglow of our creation, but at the final moments of a universe long gone. This leads to a staggering implication for our own place in the cosmos. If the cycles continue, with each new eon building upon the information of the last, then complexity and structure could evolve over cosmic timescales far beyond our comprehension. The emergence of life and consciousness in our universe may not be a one-time fluke, but a natural step in this infinite progression. Our thoughts, our awareness, and our very sense of being could be part of an endless cosmic evolution, a thread of understanding woven through the fabric of multiple realities. Are we momentary flickers in a single cycle, or are we participants in a story that has been told and will be told forever? Another profound vision of cosmic rebirth reimagines the very fabric of our reality. Picture our universe not as an isolated expanse, but as a vast three-dimensional membrane or brain floating within a higher dimensional realm. This is the core of the Ekpyrotic universe model, where our entire cosmic history is driven by a majestic, rhythmic dance between parallel worlds. In this breathtaking scenario, the Big Bang was not a singular creation from nothing, but the explosive aftermath of a collision. Our brain periodically smashes into a neighboring brain, and the sheer, unimaginable kinetic energy of that impact is instantly transformed into the hot, dense fireball of particles and radiation that marks the start of a new cycle. The universe then expands and cools much as we observe, allowing galaxies to form and life to emerge. But the story does not end with endless expansion. Dark energy, that mysterious force pushing our cosmos apart, may serve a dual purpose here. After driving the brains apart following their collision, its influence could slowly wane over trillions of years. This would allow the relentless pull of gravity to gradually draw the brains back together, setting the stage for another cosmic collision and another rebirth. This elegant cycle naturally solves some of the biggest puzzles in cosmology. Why is our universe so remarkably uniform, with the cosmic microwave background appearing almost identical in every direction? The standard model requires a brief period of hyper-fast inflation to smooth everything out. But in the Ekpyrotic model, the long, slow approach of the brains before collision naturally stretches and flattens the cosmos, ironing out any wrinkles and creating the homogeneity we see, all without needing a separate inflationary epoch. Each collision is not a perfect replica of the last. The physics could shift slightly with every new cycle. The strength of gravity, the mass of an electron, or the other fundamental constants might be randomly reset each time. This introduces a form of cosmic evolution. Only those cycles with constants fine-tuned for complexity, allowing for the formation of galaxies, stars, and planets, would be able to host observers like us. We exist in a cycle where the numbers just happen to be right. The mathematics underpinning this vision are drawn from the deepest wells of theoretical physics, namely string theory and M-theory, which posit these extra-spatial dimensions. But could such an ethereal idea ever be tested? The answer is a tentative yes. The titanic collision of brains would have sent powerful ripples through spacetime itself, generating a unique background of primordial gravitational waves. Future observatories might one day detect the faint whisper of this signal. Alternatively, the specific pattern of the collision could have left a distinct, non-random signature imprinted on the cosmic microwave background, a fossilized bruise waiting to be found. Are we living on the surface of a reality that is periodically reborn through contact with another world? But what if the universe never reaches a true point of infinite density? There is a third, profoundly elegant mechanism for cosmic rebirth, one that takes us into the quantum heart of reality itself. Imagine the entire cosmos contracting, all galaxies drawing closer, space itself squeezing tighter and tighter. Classical physics tells us this collapse would end in a singularity, a point of infinite density where all known laws fail. Yet, a revolutionary theory suggests that at the final, most extreme moment, something miraculous occurs. The universe does not end, it bounces. This is the promise of loop quantum cosmology, an application of loop quantum gravity to the entire universe. This framework proposes that space itself is not a smooth, continuous fabric, but is woven from tiny, indivisible loops, a kind of quantum geometry. When the universe contracts to about 1 trillion times the density of water, these quantum effects become dominant. They generate an immense repulsive force, a cosmic springboard that counteracts gravity's crushing pull. Instead of a catastrophic singularity, the universe undergoes a grand, smooth transition from contraction to expansion. It is a cosmic rebound, a quantum bounce. In that fleeting, transcendent moment, the universe passes through a phase where classical general relativity is no longer valid. The very concepts of space and time as we understand them dissolve into a quantum foam. Yet, this is not chaos. It is a state governed by precise quantum geometric laws, allowing for a seamless, non-singular bridge from the end of one cosmic cycle to the beginning of the next. This model naturally resolves the dreaded singularity problem, eliminating the need for a point of infinite anything. It provides a clean, physically plausible mechanism for a truly cyclic universe. But how could anything, any information, possibly survive such an extreme transformation? The answer may lie in quantum entanglement and correlation. The intricate quantum relationships between particles, the very threads that weave the fabric of reality, might be robust enough to persist through the bounds. The universe's quantum state could maintain a form of coherence, carrying a subtle imprint of its previous structure into the new expansion. In this view, the information is not stored on a surface or in a collision, but is woven into the fundamental quantum code of spacetime itself. This idea is not just a beautiful theory, it makes testable predictions. the quantum bounce would have left a specific, faint signature in the polarization patterns of the cosmic microwave background, a unique swirl in the oldest light. Future ultra-sensitive telescopes are searching for this very fingerprint. If found, it would be direct evidence that our universe was born from a bounce, not a bang from nothing. This quantum perspective challenges our deepest intuitions, suggesting that at the most fundamental level, reality operates on principles that defy our classical expectations of beginnings and endings. The universe may not die in fire or ice, but simply rebound, forever renewing itself from its own quantum core. A cosmic DVD containing the entire universe sounds like science fiction, yet this is the profound implication of the holographic principle. Our familiar three-dimensional reality, with its galaxies, planets, and people, might be a magnificent projection, a hologram encoded on a distant, two-dimensional surface. This radical idea did not emerge from pure speculation. It was born from the thermodynamics of black holes, where information about everything that falls in is not lost but painted onto the event horizon. If a single black hole can store its contents on its surface, could the entire cosmos operate on the same principle? Our universe may be encoded on its own boundary, the cosmological horizon from which light will never reach us. This transforms our understanding of what reality truly is. We are not living inside a vast, solid container. We are living within a projection, a cosmic shadow play of breathtaking complexity. For a cyclic universe, this offers the most elegant solution yet for memory preservation. The information that defines our cosmos, the specific arrangement of every galaxy, and the history of every star, is not stored within the space we inhabit. It is written on the walls, on the two-dimensional surface at the edge of everything. When one cosmic cycle ends, that boundary description may be all that remains. It persists, a stable, informational fossil, even as the interior universe dissolves into a fiery singularity or evaporates into radiation. Then, as the new universe bursts into existence, that preserved data is read back in, decoded, and projected once more into a new three-dimensional reality. The cycle does not create a perfect copy, but it carries forward the essential blueprint. Think of it like a cosmic computer rebooting. The hardware undergoes a dramatic reset, but the operating system and the core files are saved on a separate, protected drive. When the system powers up again, it loads that saved information, creating a new yet familiar world. This vision connects deeply to the idea of the universe as a quantum computer, constantly processing the information that constitutes reality itself. The very laws of physics could be the software this cosmic computer is running. This leads to a staggering question about our own place in this process. If our minds, our consciousness, are also patterns of information, then are we, too, part of this cosmic data stream? Is our awareness a temporary, localized expression of the universe processing information about itself? The holographic principle suggests that at the most fundamental level, reality is not made of matter or energy, but of bits. We are living in a story written in the indelible language of information, a story that may be infinitely retold. The universe might have a family tree. Lee Smolin proposed a theory where cosmic evolution operates on principles strikingly similar to biological natural selection. In this vision, black holes are not just gravitational traps or information vaults, they are cosmic wombs. Each time a black hole forms, the extreme conditions at its core could trigger the birth of an entirely new universe, a baby cosmos budding off into its own dimensions. And just as children inherit genes from their parents, these new universes inherit the fundamental physical constants from their progenitor. But there is a twist, a cosmic mutation. With each new birth, the constants of nature, like the strength of gravity or the mass of an electron, might be randomly tweaked. This introduces variation, the raw material for evolution. Now imagine a cosmic Darwinism unfolding across eons. Which universes survive and thrive in the grand multiverse? The ones that are most fecund, that produce the most offspring. A universe that, by chance, has physical constants perfectly tuned to create an abundance of black holes will spawn countless baby universes, passing on its fruitful parameters. A universe with constants that hinder black hole formation will be an evolutionary dead end, a branch on the cosmic tree that produces no fruit. Over countless generations, this relentless selection pressure would steer the multiverse toward universes whose laws are optimized for one thing: creating more black holes. This provides a breathtakingly elegant explanation for the fine-tuning we observe in our own cosmos. Why is the force of gravity so perfectly balanced, allowing for long-lived stars that can eventually collapse into black holes? Why is the cosmological constant so small, permitting vast galaxies to form? It might be because these are the parameters that maximize cosmic reproduction. Our universe is not fine-tuned for life by a divine hand, but for black hole fecundity through a blind, evolutionary process. Life, in this view, could be a fortunate byproduct of a cosmos that is exceptionally good at making more of itself. This theory is not just a philosophical marvel, it makes testable predictions. It suggests there should be an upper limit on the mass of neutron stars, ensuring they can collapse into black holes more easily. It also predicts that the processes leading to black hole formation, like certain types of supernova, should be as common as physically possible. Our observations are beginning to probe these very predictions, checking our universe's family history against the rules of cosmic inheritance. How does complexity emerge from such a stark evolutionary goal? A universe fine-tuned for black holes is also a universe with stable atoms, long-lived stars, and swirling galaxies, all necessary ingredients for the cosmic nurseries where black holes are born. The intricate structures we see, from spiral arms to planetary systems, are all part of a grand cosmic ecosystem geared toward replication. This transforms our perspective entirely. We are not living in a random universe, but in one that is the product of a long and successful evolutionary line, a cosmos built for creating more cosmos. What does it mean that our reality itself is subject to the same principles of selection and inheritance that govern life? Every star in the night sky is a miniature version of the cosmic cycle. Their brilliant lives and dramatic deaths are a masterclass in recycling on a scale we can almost comprehend. A star like our Sun spends billions of years peacefully fusing hydrogen into helium in its core, but this is only the first step. For more massive stars, the fusion process continues, forging progressively heavier elements like carbon, oxygen, and neon in concentric shells, like the layers of a cosmic onion. This stellar alchemy culminates in the creation of iron, an element that absorbs energy rather than releasing it. This is the star's point of no return. With its energy source cut off, the core collapses in less than a second, triggering a cataclysmic rebound explosion known as a supernova. The blast is so violent that it forges every element heavier than iron, from the gold in a wedding ring to the uranium in the Earth's crust, and hurls them all across interstellar space. This enriched debris, this cosmic fertilizer, then mingles with vast clouds of gas and dust. Under the gentle pull of gravity, these clouds, now seeded with the elements for planets and life, begin to collapse, giving birth to a new generation of stars and worlds. The beautiful, glowing clouds we call planetary nebulae are the gentler final acts of smaller stars, their outer layers drifting away to provide the raw materials for future solar systems. We can see this process in action today. The Crab Nebula is the expanding remnant of a supernova witnessed by astronomers in the year 1054. Within its swirling filaments, new stars are already beginning to coalesce from the ashes of the old. This means the calcium in your bones, the oxygen you breathe, and the iron in your blood were all forged in the heart of a long-dead star and delivered across the galaxy by its spectacular death. You are not just living in the universe, you are a collection of its most ancient, recycled artifacts. This stellar life cycle is a perfect microcosm of the grand universal process, a proof of concept that endings create new beginnings. If stars can efficiently reuse their materials across billions of years, could the entire cosmos be operating on the very same principle, just on an almost unimaginably larger scale? Our own Milky Way is a vast, spinning ecosystem of stellar birth and death. Within its spiral arms, a grand and continuous recycling of matter unfolds on a scale that dwarfs anything we can experience. This is not a static celestial painting, but a dynamic, living engine. Galaxies like ours act as cosmic lungs, inhaling pristine hydrogen gas from the intergalactic void. This gas cools and condenses into colossal clouds, the stellar nurseries where new stars are born. These stars then live out their lives, some ending in gentle puffs of enriched gas and others in violent supernova explosions that blast their forged elements back into the galactic environment. This expelled material does not simply vanish. It joins a great galactic fountain, rising above the galactic plane and eventually raining back down, seeding future generations of stars and planets with the heavy elements necessary for life. The very rotation and structure of our galaxy, its elegant spiral arms, are a direct result of this relentless churn, a pattern sustained by countless cycles of stellar creation and destruction over billions of years. The process reaches its most dramatic pitch when entire galaxies interact. A slow-motion dance of gravity pulls two spiral galaxies together, their delicate structures stretched and distorted. This cosmic collision triggers an immense burst of new star formation, a starburst that rapidly consumes vast reservoirs of gas. It is a frenzy of recycling on an almost unimaginable scale, where the merger itself forges a new, often elliptical, galaxy from the raw materials of the two original systems. Our own Milky Way is destined for such a transformation. In about 4 billion years, it will begin its long embrace with the Andromeda Galaxy. This monumental event will not be a destructive crash, but a creative merger, recycling both majestic spirals into a single, new elliptical galaxy, fundamentally resetting their evolutionary clocks. At the heart of this galactic ecosystem sits a master regulator, the supermassive black hole. These immense gravitational anchors are not passive occupants. When they actively feed on surrounding matter, they can power brilliant quasars or drive colossal winds that surge through the galaxy. This is a feedback mechanism of breathtaking power. These outflows from the central black hole can heat surrounding gas, preventing it from cooling and forming new stars, or they can violently expel material entirely, effectively shutting down star formation for a time. This black hole feedback acts as a cosmic thermostat, governing the rate at which a galaxy recycles its gas into stars. It ensures the galaxy does not burn through its fuel too quickly, allowing for a long, stable evolutionary process where multiple cycles of life can unfold. The heavy elements cast out by supernova and galactic winds do not remain locked within their home galaxy. They eventually escape, polluting the vast intergalactic medium with the seeds of planets and life. This means the iron in your blood and the silicon in the ground beneath your feet may have been forged in a galaxy far beyond our own, a visitor from a different cosmic ecosystem that became part of ours through this grand intergalactic exchange. These nested cycles, from the life of a single star to the collision of entire galaxies, reveal a universe operating on principles of renewal at every scale. If stars and galaxies are constantly being reborn from their own ashes, could this very same pattern be the fundamental rule for the cosmos itself? This invisible cosmic scaffolding holds entire galaxies together. Dark matter makes up 27% of everything in the universe, a vast, unseen ocean whose gravitational pull shapes the cosmos we observe. While dark energy drives the universe apart, dark matter is the great cosmic architect, weaving the grand structures that allow for stars, planets, and life itself. Its role in the endless cycle of creation and collapse may be even more profound than we ever suspected. After a cosmic rebirth, as a new universe expands from its fiery beginning, dark matter acts as the essential gravitational anchor. Its halos, those vast, diffuse clouds that envelop galaxies, provide the initial framework. Ordinary matter, the stuff we see, is then drawn into these pre-existing gravitational wells, cooling and condensing to form the first stars and galaxies. Without this dark matter scaffolding, the universe would be a formless, expanding cloud, unable to coalesce into the brilliant islands of light we see today. In a cyclic universe, this structuring process must happen again and again. Dark matter may be the constant, the persistent element that guides the reformation of cosmic architecture with each new cycle. But how could something as seemingly passive as dark matter survive a universal collapse or a fiery bounce? Some theories propose a fascinating connection between dark matter and the primordial black holes from previous cycles. What if a portion of dark matter is actually composed of the remnants of black holes that evaporated in a prior cosmic era? These ancient, fundamental cinders would carry the gravitational imprint of their past, seeding the new universe with ready-made structures. The very nature of the dark matter particle could determine the efficiency of cosmic recycling. Is dark matter cold and slow-moving, allowing it to clump easily and form galaxies quickly? Or is it warm and fast, leading to a slower, more drawn-out process of structure formation? The answer dictates the rhythm and pace of each cosmic cycle, influencing how quickly galaxies can form, stars can live and die, and black holes can emerge to potentially seed the next universe. We are on the verge of potentially detecting this mysterious substance, deep underground, in laboratories shielded from cosmic rays. Experiments like LUX Zeppelin and its successor Xeno-NNT are waiting for the incredibly rare interaction between a dark matter particle and the nucleus of a xenon atom. A single, fleeting signal could unlock the identity of this cosmic architect. Could dark matter be more than just a gravitational guide? If information is the universe's most resilient currency, could dark matter particles themselves be carriers of data between cycles? Their stable, weakly interacting nature makes them ideal candidates for cosmic messengers. They could be the librarians of the cosmos, holding faint imprints of previous universes within their quantum states, subtly influencing the initial conditions of the next. To truly understand the eternal return of the cosmos, we must first comprehend the invisible force that gives it shape and form. The silent, persistent pull of dark matter may be the steady heartbeat that powers the universe's endless rhythm of life, death, and rebirth. Our cosmic cycle may not be a solitary rhythm. Picture our universe not as the only one, but as a single bubble floating in an infinite, frothing sea of cosmic foam. This is the multiverse, a vast ensemble where countless other universes, each with their own unique laws and timelines, bubble into existence and fade away. In this grander landscape, the cycle of creation and collapse we experience could be just one pattern among an infinite variety. Some of these cosmic bubbles might be stillborn, collapsing almost instantly. Others could expand into vast, sterile emptiness, A precious few, like our own, might find the perfect balance, allowing for the long, slow dance of galaxies, stars, and life. This framework, known as eternal inflation, suggests that the background of reality is in a state of perpetual, hyper-fast expansion. Within this seething expanse, pockets occasionally drop out of this inflationary state, their energy converting into the hot, dense soup of a new Big Bang, giving birth to a fresh universe with its own distinct character. This process is not a one-time event but a continuous, endless genesis, a cosmic churn producing new realities all the time. The physical constants that govern each bubble, the strength of its forces and the masses of its particles, could be set randomly. This creates a form of cosmic natural selection on a scale beyond comprehension. Universes that, by chance, have constants conducive to longevity and structure are the ones that can persist long enough to develop complexity and perhaps even create black holes that seed further generations. Our universe's finely tuned parameters, which allow for such intricate recycling, may not be a miraculous coincidence. They could simply be the result of our bubble having a fortunate draw in the multiverse lottery. But could these bubbles interact? Even though they are separate realms, their gravitational fields might subtly influence one another through the fabric of the higher dimensional space they inhabit. The collision of two bubbles could be a catastrophic event, or it could be the very mechanism that triggers a new cycle of rebirth within one or both of them. The strange cold spots in our cosmic microwave background could be the bruises from such a long-ago encounter with a neighboring universe. This multiverse perspective expands the idea of recycling to a truly cosmic scale. Our universe's entire history, from its first instant to its final fate, might be just one thread in an infinite tapestry of becoming. How does the existence of this wider cosmic landscape affect our own cycle? The gravitational pull from other bubbles could subtly tweak the rate of our expansion or the timing of our contraction. The very information that defines our reality might not be confined within our observable horizon, but could be part of a larger data exchange between neighboring realms. We are not just participants in a cycle, but citizens of a vast, breathing multiverse, where endings and beginnings are the most common events of all. Our everyday reality is built upon an undeniable flow from past to future, an arrow of time that seems as absolute as gravity. We remember yesterday but not tomorrow. A broken cup shatters but never spontaneously reassembles. This relentless forward march is deeply tied to the universe's own expansion and the corresponding rise in entropy, the measure of disorder. As the cosmos grows and evolves, disorder increases, and this gives our lives their irreversible direction. But if the universe is truly cyclic, what happens to time's arrow when one cycle ends and the next begins? This question strikes at the very heart of our experience of reality. One provocative proposal suggests that during a cosmic contraction phase, the arrow of time could actually reverse. In this mind-bending scenario, as the universe collapses toward its final state, entropy would begin to decrease. From our perspective, this would look like a universe spontaneously healing itself, with scattered smoke particles gathering to form a perfect cigarette, shattered glass pieces flying up to assemble into a pristine cup on a table, and light being absorbed into stars rather than radiating away. But this creates a profound philosophical puzzle about consciousness. Would beings in that contracting phase perceive themselves as living forward, with their memories accumulating of what we would call their future? Or would their entire experience of reality be the inverse of our own? It is a dizzying thought that challenges the very core of what we consider the self. Other, perhaps more elegant, models avoid this reversal. They propose that the arrow of time is maintained consistently through each cycle by subtle quantum gravitational effects. In these theories, time's direction is a local phenomenon unique to each individual cosmic cycle. The end of one universe and the beginning of the next might be a boundary where our conventional understanding of cause and effect simply breaks down. The flow of time we experience is not a river flowing endlessly from a past cycle into our present, but a new river springing to life with each new cosmic dawn. This immediately raises a haunting question about memory and identity. If time is not continuous across the transition, how could any information, any memory of a previous cycle possibly be preserved? The answer might lie beyond our classical understanding. While the continuous narrative of time may be reset, the quantum correlations and entangled states that underpin reality could persist. The universe would not remember its past in a story-like form, but as a foundational template, a set of initial conditions inherited from its predecessor. So how would consciousness, that fleeting pattern of information processing, experience such a transition? We cannot know for certain. Perhaps at the boundary between cycles, all conscious experience simply ceases, only to potentially re-emerge in a new form in the next universe with no memory of what came before. Or perhaps in a way our brains cannot comprehend, the essence of awareness is tied to that deeper quantum substrate, continuing its journey in a new physical form. These are not just scientific puzzles, but the deepest metaphysical mysteries we can contemplate. They force us to ask what we truly are, and whether the flow of time itself is a fundamental property of the cosmos, or merely a temporary experience within one chapter of an infinite story. The universe may remember itself across rebirths, its memory written not in stone but in the fundamental fabric of reality. This concept of cosmic memory suggests that information, the blueprint of what was, survives the fiery transition between cycles, creating a meaningful evolution rather than a series of random resets. Imagine if every time you booted up a computer, it retained a faint echo of the documents you wrote last time, allowing you to build upon your previous work instead of starting from a blank page. Our cosmos might operate on a similar principle, using several profound mechanisms to preserve its own history. One possibility is through gravitational waves, the ripples in spacetime from colossal events like black hole mergers. These ripples are so fundamental that they might cross the boundary between universes, imprinting their patterns onto the next cycle's cosmic microwave background as faint, concentric rings. Another pathway is quantum entanglement, the mysterious connection that links particles across vast distances. The intricate web of these quantum relationships could be robust enough to persist through a cosmic bounce, carrying a subtle, encoded template of the previous universe's structure into the new expansion. The most radical preservation method is holographic encoding. If our three-dimensional reality is a projection from a two-dimensional surface at the cosmic horizon, then that surface becomes the ultimate hard drive. When one cycle ends, that boundary description remains stable, a permanent record. As the new universe bursts into life, it reads this saved data, projecting a new reality that inherits the essential information from its predecessor. This is not a perfect copy, but a new iteration built upon an ancient foundation. If this is true, then the mathematical laws of physics, the constants that govern reality, might remain the stable, unchanging framework. Within that framework, the specific arrangements of matter and energy, the galaxies and the life forms they host, could vary with each cycle, creating infinite diversity within a consistent rule set. This leads to a staggering implication for consciousness itself. If our awareness is a complex pattern of information processing within the universe, could that pattern, in some fundamental way, also be part of this preserved data? We are not just passive observers of the cosmic cycle, but potentially active participants in a grand, self-learning system. the universe, through beings capable of thought and wonder, is gradually coming to understand its own nature. With each new cycle, it has the potential to build upon that accumulated understanding, creating ever more intricate forms of complexity and awareness. How much does the cosmos learn about itself through this endless process of recycling? The answer hinges on the resilience of information, the one currency that might truly be eternal. The subjective feeling of being you, that inner light of awareness, might not be a temporary flicker in a single cosmic cycle. If the universe truly recycles itself through endless rebirths, then consciousness itself could be a fundamental feature of reality, woven into the fabric of space-time rather than just an accidental byproduct of brain chemistry. This idea resonates with ancient philosophical traditions, from the Atman of Hindu philosophy to the animating spirit of Stoicism, which saw mind as an intrinsic part of the cosmos. Modern thinkers are revisiting this notion, proposing that consciousness may be a fundamental property, like mass or charge, that the universe possesses at its most basic level. This perspective directly confronts the hard problem of consciousness, the puzzle of why and how physical processes in a lump of gray matter give rise to the rich, private world of sensations, thoughts, and emotions you're experiencing right now. If consciousness is indeed fundamental, then it does not emerge from matter. Instead, matter organizes itself in ways that channel or express this underlying conscious field. A brain, in this view, is not a creator of consciousness but a sophisticated receiver or amplifier, tuning into a quality that is already everywhere. Consider a radio. It does not create the music it plays, it simply translates invisible radio waves into audible sound. Your brain could be a cosmic radio, translating a fundamental field of proto-consciousness into your individual stream of thought. What are the implications for the cosmic cycle? With each new universe, the fundamental field of consciousness would be present from the very first moment. As the cosmos evolves, matter arranges itself into increasingly complex structures, from stars to galaxies to neural networks. Each new cycle, inheriting the informational blueprint of the last, has the potential to create even more sophisticated vessels for this cosmic awareness. Over eons of cosmic time, consciousness could evolve toward deeper and more unified states of understanding, a slow march toward cosmic enlightenment where the universe becomes fully aware of itself through its inhabitants. This transforms the coldest, most sterile vision of a cyclic cosmos into a story of profound purpose. Your individual consciousness is not an isolated accident. It is a localized expression of the cosmos waking up. You are a momentary focus point for the universe to experience itself, to feel wonder, to ask questions about its own origin. The relationship between your individual mind and this proposed cosmic consciousness is not one of ownership, but of participation. You are a whirlpool in a vast river of awareness, a temporary pattern with its own unique identity, yet fundamentally made of the same flowing water as the whole. Your thoughts and experiences are the universe thinking and experiencing through you. These are, of course, speculations that dance on the edge of science and philosophy. Yet they are grounded in the same deep questions that drive our search for a theory of everything. They suggest that the ultimate reconciliation of physics may require us to include the observer, the conscious mind, as an integral part of reality's equations. If the cosmos is an endless, self-recycling system, then perhaps its greatest product is not stars or galaxies, but understanding itself. These grand cosmic visions demand more than just mathematical beauty. They require the hard, unforgiving light of evidence. The race is on to find the fingerprints of a previous universe, and scientists are building the tools to do it. One of the most promising avenues is the search for primordial gravitational waves. Future space-based observatories like the Laser Interferometer Space Antenna, or LISA, will open a new window into the cosmos. This trio of satellites, flying in a precise gravitational dance millions of kilometers apart, will detect the faintest ripples in spacetime. It could listen for the specific hum generated by a cosmic bounce or the collision of brains, a whisper from the very moment of our universe's birth that carries the echo of what came before. These waves are so ancient that they would have been imprinted directly onto the fabric of reality during the universe's first instance, offering a pristine record untouched by later cosmic events. Simultaneously, the next generation of cosmic microwave background telescopes will scrutinize the ancient sky with unprecedented precision. They will hunt for the subtle, non-random patterns predicted by models like conformal cyclic cosmology, those concentric rings that could be the bruises from supermassive black hole collisions in a prior eon. They will also search for a specific type of polarization in this primordial light, a unique swirl known as B-mode polarization that could be the smoking gun for a violent, inflationary beginning or a graceful quantum bounce. Each anomaly found in this fossilized light is a potential message from the other side of the Big Bang. Even the large-scale structure of the universe holds clues. The precise way galaxies cluster together, forming a cosmic web of filaments and voids, is a direct result of the initial conditions set at the beginning. If our universe was born from a cyclic process, the statistical distribution of these galaxy clusters might show a faint but detectable imprint, a signature of pre-Big Bang physics written into the architecture of everything we see. The James Webb Space Telescope is already contributing to this detective work by peering back at the very first galaxies. Their size, maturity, and distribution so early in cosmic history provide critical constraints, telling us how quickly structure could form and helping rule out or support various models of cosmic evolution. Some of the evidence might be closer to home, hidden in the fabric of spacetime itself. Certain cyclic models predict the formation of cosmic strings, incredibly dense, one-dimensional defects in reality, thinner than an atom but stretching across the entire universe. These cosmic scars would warp spacetime around them, creating double images of distant galaxies and leaving a distinct signature in the cosmic microwave background. Their detection would be a monumental breakthrough, pointing directly to a phase transition in the early universe consistent with a cyclic origin. For the first time, we are not just speculating about these ideas, we are building the instruments to test them. The scientific method, with its slow, meticulous accumulation of data, is gradually illuminating the deepest questions of our origin. A single, unexpected signal from LISR or a strange pattern in the microwave background could force us to rewrite the story of the cosmos. How long will it take to know if we live in a universe that truly recycles itself? The answer blows in the cosmic winds, waiting for our next great telescope to catch its whisper. The idea that our universe endlessly recreates itself forces us to confront some of the deepest philosophical questions imaginable. The German philosopher Friedrich Nietzsche grappled with a concept he called the eternal return, a thought experiment where the universe repeats itself in every detail infinitely. He proposed that every joy, every pain, and every mundane moment of your life would happen again, exactly the same, an infinite number of times. Ancient cultures from the Stoics to various Eastern traditions also spoke of vast cosmic cycles, suggesting a deep, intuitive human understanding that time might be circular rather than a one-way street. Now, modern cosmology provides a potential scientific framework for these ancient musings. This convergence of philosophy and physics is not just an academic curiosity, it strikes at the very core of how we find meaning. If the cycles are truly identical, then you are reading these words not for the first time but for the billionth, and you will read them again 1,000,000,000 times more. This can be a terrifying thought, a cosmic Groundhog Day with no escape from our choices and sufferings. Yet it can also be profoundly comforting, suggesting that every beautiful moment, every act of love, is etched permanently into the fabric of reality, destined to be relived forever. But if the cycles are evolutionary, as many scientific models suggest, then the narrative shifts dramatically. We are no longer trapped in an endless loop, but are active participants in a grand, cosmic learning process. Every discovery we make, every piece of art we create, and every moral choice we take becomes a small but vital contribution to the universe's slow journey toward greater complexity and understanding. In this view, our lives are not meaningless repetitions but essential chapters in a story that has been told for eons and will continue long after we are gone. This perspective fundamentally alters the weight of our actions. The kindness you show another person, the knowledge you pursue, the legacy you build, these are not just fleeting moments in a single, linear life. They could be part of a cosmic inheritance, a data stream of consciousness and culture that subtly influences the initial conditions of a future universe. How does this change your relationship with the world? If your consciousness is a temporary expression of a cosmos that is slowly waking up to itself, then your very act of wondering about these mysteries is the universe thinking about its own nature. Your life becomes a vital instrument in this grand self-discovery. The philosophical implications ripple outward, touching ethics, spirituality, and our sense of purpose. It suggests that our drive to create, to connect, and to understand is not a biological accident, but may be woven into the fundamental operating system of a reality built on cycles of renewal. In an endlessly recycling cosmos, the quest for meaning itself becomes the universe's most enduring project. Long before telescopes or quantum theory, humanity gazed at the stars and saw a story of eternal return. The ancient Hindu texts describe a cosmos breathing in a vast rhythm, where universes are created, sustained, and dissolved in cycles called kalpas, each lasting an astonishing 4.32 billion years. This is not a random number, but a figure that echoes the scale of geological and cosmic time, a profound intuition of reality's cyclical nature. On the other side of the world, the Maya developed a cosmology of interlocking calendars so precise they could track planetary movements across millennia. Their long count calendar measured vast eras, culminating in resets that were not endings, but transitions into New World ages. For them, time was not a straight line into oblivion, but a series of nested, sacred cycles. The Greek philosopher Heraclitus captured this idea with his famous assertion that you cannot step into the same river twice, for fresh waters are ever flowing in upon you. He saw the cosmos itself as an ever-living fire, kindling in measures and going out in measures, a perpetual process of transformation. This pattern repeats in indigenous traditions from the Hopi to the Aboriginal Australians, whose dreamtime connects a timeless, cyclic creation to the living landscape. These are not primitive myths, but sophisticated frameworks for understanding a universe in flux. How did cultures that never communicated arrive at such similar conclusions? They observed the world around them, the cycles of day and night, the seasons, the birth and death of generations, and projected this fundamental pattern onto the cosmos itself. Their wisdom suggests a deep, almost instinctual recognition that existence is built on rhythms of renewal. This creates a fascinating tension with our modern, linear view of history and progress. We see time as an arrow moving from a primitive past to a technological future. Yet these ancient systems reconciled the two by seeing linear history as a small story unfolding within a much grander, circular time. The daily news and your personal life story move forward, but they are all contained within the great turning wheel of cosmic seasons. The persistence of this idea across millennia and continents is a powerful clue. It hints that the concept of a cyclic universe resonates with something fundamental in the human mind, and perhaps in the nature of reality itself. Our scientific search for evidence of cosmic recycling is not a new endeavor, but a modern expression of one of humanity's oldest and most profound intuitions. Trillions of years from now, the cosmic landscape will be utterly transformed. Based on our best measurements, the universe's expansion will continue to accelerate, driven by the relentless push of dark energy. One by one, the stars will vanish. First, the most massive blue giants will burn out in spectacular supernova, leaving behind neutron stars and black holes. Then, medium-sized stars like our Sun will slowly exhaust their fuel, puffing away their outer layers and fading into dense, cooling embers known as white dwarfs. The smallest, dimmest red dwarfs, which burn their fuel with incredible frugality, will be the last sentinels of light, glowing for perhaps 10 trillion years before they too finally wink out. The era of starlight, the epoch that gave birth to our world and every living thing we know, will be over. In this deepening twilight, galaxies will undergo their own majestic transformations. The Milky Way and Andromeda will have long since merged, their spiral arms stretched and woven into a single, giant elliptical galaxy. Over even longer timescales, this new galaxy will drift through the cosmic web, eventually merging with others into a vast, amorphous supercluster, the last great city of stars in an ever-darkening expanse. At the centers of these galactic remnants, supermassive black holes will continue their slow feast, growing ever larger by consuming the occasional stray star or gas cloud that wanders too close. For a time, these black holes will be the only sources of significant energy, their accretion disks glowing faintly in the profound blackness. Then, on a timescale so vast it defies human intuition, the very fabric of matter itself may begin to unravel. Current theories suggest that protons, the stable building blocks of all atomic nuclei, might not be permanent. They could decay with a half-life exceeding 10 to the 34 years. If this is true, then all leftover matter, the white dwarfs, the neutron stars, even the planets and asteroids, will gradually disintegrate into a thin soup of radiation and subatomic particles. The universe would approach a state known as heat death, a cold, nearly uniform sea of energy where nothing ever happens again. This is the ultimate end predicted by classical thermodynamics. But in a cyclic cosmos, this bleak fate is not an ending. This state of maximum entropy and silence is not a final grave, but a phase of deep recalibration. It is the necessary quiet, the cosmic inhale, that precedes the next great creative breath. The precise timeline for this transition hinges on mysteries we have yet to solve. Will dark energy maintain its strength, or will it decay, allowing gravity to one day pull the cosmos back together? The answer lies in physics we have not yet discovered, governing the vacuum of space itself. If humanity has descendants, they would be unrecognizable to us. They would not be creatures of flesh and blood living on planetary surfaces. To survive the fading of stars and the decay of matter, they would have to become something else entirely. Perhaps they would transfer their consciousness into more durable substrates, living as complex patterns of information in vast, orbiting supercomputers powered by the last flickers of stellar remnants or the subtle energies of rotating black holes. Their perception of time would be vastly different, their thoughts unfolding over millennia as they navigate a cosmos growing colder and darker with each passing eon. Their greatest project would be the preservation of knowledge and consciousness against the dying of the light, a desperate fight to carry the memory of their origins across the unimaginable gulf toward the next cosmic dawn. This grand future perspective illuminates a profound duality of our existence. Everything we hold dear is breathtakingly transient, a fleeting spark in a fire that will one day cool to ash. Yet, if the cycle holds, that ash is the very substance from which a new fire will be kindled. Our brief moment of awareness, our capacity to look up and wonder about these very questions, is part of a continuity that may stretch across eternity. How could any form of intelligence forged in such a universe not feel a deep ancestral pull to ensure its story is told again? The ultimate goal of technology may not be to conquer the universe, but to harmonize with its deepest rhythms. If the cosmos truly operates on cycles of rebirth, then our most advanced future technologies could be those designed not to resist this process, but to participate in it. Imagine a civilization that has mastered the universe not by battling entropy, but by learning to surf the waves of cosmic renewal. Their greatest achievement would be to build systems that can endure the transition between one cosmic cycle and the next, carrying the torch of knowledge and consciousness across the unimaginable gulf of a universal reset. This is not about building a bigger rocket, but about engineering a legacy that can outlive the stars themselves. Such a civilization would likely develop matter recycling technologies of almost magical efficiency. They would watch how supernovae forge heavy elements and how galaxies churn gas into new stars, and they would replicate these processes on demand. Their cities and ships would be constructed with materials that are perpetually broken down and reassembled, creating a closed-loop economy that mimics the cosmic cycle on a local scale. Waste would be an obsolete concept, as every atom would be tracked and repurposed with the same relentless efficiency that the universe itself employs. Their power sources would not rely on burning finite fuels, but on tapping into the fundamental energies that drive the cosmic cycle itself. They might learn to draw power from the quantum vacuum, the seething energy of empty space that persists even when all stars have died, or even from the gravitational potential of the cosmic contraction phase, harvesting energy from the universe's own inward collapse. Communication would also undergo a radical transformation. How do you send a message when the recipient may not exist for trillions of years in a universe with entirely different physical laws? They would develop information systems that are encoded not in fleeting electromagnetic signals, but in more fundamental substrates. They might imprint data onto the fabric of space-time using gravitational waves, creating a cosmic bulletin board whose messages could ripple across the boundary of a bounce or a collision. Or they might use quantum-entangled particles in ways we cannot yet conceive, creating a network where information is shared instantaneously, perhaps even surviving a transition by being embedded in the very quantum code of reality. The most profound technological challenge would be the ultimate backup. How does a civilization preserve its entire history, its art, its science, and the essence of its consciousness through the fiery end of one universe and the blazing beginning of the next? The solution might be holographic. If our reality is a projection from a two-dimensional surface, then the ultimate act of preservation would be to encode the sum total of a civilization's knowledge onto that cosmic hard drive. They would find a way to write their story directly onto the boundary of the universe, ensuring it becomes part of the initial conditions for the next cycle. In a sense, they would seed their own cosmic ancestry, ensuring that the next universe is born with their memory, their achievements, and their very identity woven into its newborn fabric. This transforms our own technological aspirations from a quest for dominion into a project of cosmic stewardship. Our drive to build, to explore, and to understand could be the first, faltering steps of a process that culminates in a civilization becoming a permanent part of the universe's evolutionary story. The technologies we develop today, from quantum computing to artificial intelligence, might be the primitive precursors to tools that one day allow humanity, or whatever we become, to contribute directly to cosmic evolution. We are not just building for our own time, but potentially laying the groundwork for a legacy that could echo through eternity. What kind of message would we choose to send to our cosmic descendants, a trillion generations removed? A phoenix rising from its own ashes offers a powerful image for the cosmic cycle. This ancient myth provides a tangible anchor for one of the most abstract ideas in all of science, transforming an overwhelming scale into a story we can grasp. Effective education about cosmic recycling relies on such bridges, connecting the unfathomable to the familiar. We can frame the universe's rhythm as a breath, an eternal inhale of contraction and exhale of expansion, or as the passing of seasons on a scale spanning trillions of years. These analogies do not dumb down the science, they build a vital intuitive framework for the mathematics that follows. Interactive simulations bring the equations to life. Imagine manipulating a digital cosmos, watching a slider control the strength of dark energy, and seeing galaxies either fly apart forever or slowly reverse their course, collapsing toward a future bounce. Visualizing the cosmic microwave background as a dynamic heat map, where students can pinpoint strange cold spots and concentric rings, turns passive learning into active discovery. They are not just hearing about evidence, they are uncovering it for themselves, following the same investigative path as professional cosmologists. This process demystifies the science, revealing it as a disciplined, evidence-based pursuit. It is crucial to distinguish the solid ground of tested theory from the shifting sands of pure speculation. We teach that the expansion of the universe is a measured fact, that the cosmic microwave background is a real fossil we can analyze, and that black hole thermodynamics is a rigorous field of study. The cyclic models built upon these foundations are not wild guesses, but logical, mathematical extensions of our confirmed knowledge. Showing the historical development of these ideas is equally important. We can trace the line from ancient intuitions of cosmic cycles to Einstein's equations, to the discovery of the expanding universe, and on to modern debates about quantum gravity. This narrative demonstrates that science is a self-correcting, evolving conversation, not a collection of static facts. The ultimate goal is to make this knowledge meaningful. By connecting the calcium in our bones to the explosion of a long-dead star, we place humanity within the cosmic story. We are not just observers of the universe, we are a temporary embodiment of its recycling machinery. This perspective transforms existential awe into a profound sense of connection. How can we feel small when we are woven into a process that has no beginning and no end? Education at its best does not overwhelm with scale, but inspires with belonging, turning the vast, impersonal cosmos into a home that is continuously and miraculously reborn. Our oldest stories have always whispered the secrets of the cosmos. Creation myths from across the globe are filled not with a single genesis, but with endless cycles of world creation and destruction, a rhythmic pulse that feels strangely familiar. The ancient Hindus envisioned a cosmic rhythm of breathtaking scale, where the god Brahma's single day and night, a kalpa, spans over 4 billion years, a period that hauntingly mirrors the lifespan of our own planet Earth. In the frozen north, Norse prophecies of Ragnarok did not foretell a final end, but a great cleansing fire and flood from which the world would emerge anew, green and beautiful, populated by a new generation of gods and humans. These are not isolated tales. From the Maya to Aboriginal Australians, cultures that never met independently arrived at the same profound conclusion, that reality itself is a wheel of eternal return. This persistent pattern is a powerful clue. It suggests that long before telescopes or particle accelerators, human consciousness was intuitively grappling with a fundamental truth about the nature of the universe, a truth we are only now confirming with equations and data. Modern science has not debunked these myths. Instead, it has provided them with a rigorous language and an observational foundation. The mathematical models of a cyclic universe, whether through a conformal bounce or colliding branes, are the precise articulation of that ancient, deeply felt intuition. This convergence does not validate the specific imagery of a world serpent or a dancing god, of course. It reveals something far more significant about our place in the cosmos. It shows that the human mind, by observing the cycles of nature, the seasons, and the stars, was able to project that pattern onto the grandest possible scale and perceive a fundamental cosmic rhythm. So how does this scientific understanding transform the mythological insight? It elevates it from poetic metaphor to a plausible framework for reality. The myth becomes a cultural and psychological precursor, a story that prepared our collective imagination for the scientific revelation. This integration enriches both perspectives. Science gains a deeper cultural and philosophical context, recognizing that its quest is part of a timeless human endeavor to understand our origins. Mythology, in turn, is revitalized, its symbolic narratives resonating with a new empirical power. We are not just discovering the universe's cycles, we are remembering a truth our ancestors felt in their bones. Artists have always translated the cosmos into colors and sounds we can feel. Long before we had telescopes to see the cosmic microwave background, Renaissance painters like Hieronymus Bosch filled their canvases with visions of cosmic order and celestial spheres, depicting time not as a line but as a divine, repeating cycle. These intricate works were more than religious devotion. They were attempts to map the architecture of eternity, to give a human face to the infinite. They captured the emotional truth of a universe governed by rhythmic, recurring patterns, a truth science is now quantifying with mathematics. Today, digital artists pick up this ancient brush, using algorithms and simulation data to visualize the death of a star or the collision of galaxies. Their renderings of black holes warping starlight or the cosmic web of dark matter are not just beautiful, they are modern tools for understanding. They take the cold data of a physics paper and transform it into an immersive experience, allowing us to stand at the edge of a newborn universe or witness the last star flicker out. We do not just see the science, we feel its immense scale and profound beauty. Music, too, gives voice to this eternal rhythm. Gustav Holst's symphonic suite The Planets does not merely describe astronomical bodies, it captures their archetypal character, from the brutal, militant energy of Mars to the serene, timeless mystery of Neptune. The compositions rise, climax, and fade, mirroring the life cycles of the very worlds they evoke, creating a sonic metaphor for cosmic birth and decay. This tradition continues in the ambient soundscapes of modern composers, who use shifting textures and vast, open spaces to evoke the silent, breathing expanse of an infinite cosmos. Literature provides the narrative thread, weaving the concept of cyclic time into the very fabric of story. Dante's journey through the circles of the Inferno, Purgatorio, and Paradiso is a medieval vision of a structured, hierarchical cosmos, a moral universe with its own laws of consequence and return. In our own time, science fiction authors explore the philosophical weight of eternal recurrence, from the cyclical resets of forgotten civilizations to the cosmic wombs of black holes birthing new realities. These stories are thought experiments, allowing us to live inside the implications of a recycling universe and ask what it means for love, memory, and identity. How does this artistic interpretation complement the cold equations of science? It provides the essential emotional and psychological dimension that raw data cannot. A graph of the universe's expansion is informative, but a painting that makes you feel the loneliness of a dying star or a symphony that stirs a sense of cosmic wonder connects the idea to your own heartbeat. Art makes the unimaginable tangible, translating abstract scales into a language the human soul can comprehend. It is the other half of the conversation, the feeling that answers the fact. In the end, our quest to understand the cosmos is not just a scientific pursuit, but a deeply creative one, a dance between calculation and inspiration that together reveal a richer, more resonant truth. This vast cosmic perspective holds a mirror to our deepest fears and our most profound sources of peace. The knowledge that we are part of an endless cycle of creation and collapse can feel like a crushing weight, reducing our individual lives to insignificant specks in an infinite procession. We might ask, if the universe simply repeats itself, what meaning can my struggles and joys possibly hold? This is the shadow of cosmic awareness, a profound existential anxiety that can make our earthly concerns feel trivial and pointless. Yet, this very same perspective can also be the source of its opposite, a liberating and profound tranquility. Recognizing that we are active participants in an eternal process can lift the terrible burden of finality from our shoulders. The pressure for our single life to bear the weight of all meaning dissolves when we see ourselves as one note in a symphony that has been playing for eons and will continue long after we are gone. Your existence is not a random accident in a void, but a momentary expression of a cosmos that is continuously learning and recreating itself. This realization can transform a fear of meaninglessness into a deep sense of belonging. The sheer scale of cosmic time offers a powerful form of psychological comfort. When you are overwhelmed by a personal crisis or the relentless pace of daily life, consider the slow, patient rhythm of the cosmic cycle. Your most intense worries are unfolding within a universe that takes trillions of years to complete a single breath. This does not diminish your pain, but it places it within a context so vast that it can soften its edges, offering a quiet, humbling reassurance that this too is part of a grander, more enduring flow. At the same time, the undeniable transience of all things, from a single star to an entire universe, can ignite a fierce and beautiful appreciation for the present moment. Knowing that nothing lasts makes every experience, every connection, every flash of insight unbearably precious. The love you feel, the art you create, the knowledge you discover, these are not erased by the universe's recycling. They become part of the informational tapestry that may influence the next cosmic dawn. How different people respond to these ideas reveals much about the human spirit. Some minds are energized by the sheer grandeur, feeling a sense of freedom and possibility. Others may feel a deep unease, a cognitive vertigo from staring into the abyss of deep time. There is no single correct emotional response. The challenge and the opportunity lies in integrating this cosmic awareness into a healthy, flourishing life. How can we carry this knowledge without being crushed by it? The answer may be to see it not as a cold, abstract fact, but as a source of wisdom. We can learn from the cosmos itself, which embraces both endings and beginnings as necessary parts of a whole. We can practice letting go of what no longer serves us, trusting in the process of renewal. We can find purpose not in permanence, but in our unique capacity to contribute to this ongoing story, to add our small thread to the infinite tapestry. In the end, the cosmic perspective does not ask us to abandon our humanity. but to expand it, to find a home for our fleeting hearts within the eternal heartbeat of the universe. Our moral choices echo across timeframes that dwarf human history. When we consider that civilizations might rise and fall through endless cosmic cycles, our ethical responsibilities expand to an almost unimaginable scale. If the information that defines our universe is preserved and influences the next, then the knowledge we generate, the art we create, and the values we champion are not just for our own brief moment. They become potential seeds for future realities, a legacy inscribed not in stone, but in the fundamental blueprint of a universe yet to be born. This transforms the act of preserving human culture from a historical endeavor into a cosmic imperative. We are not merely curators for our grandchildren, but potential ancestors to intelligences that will exist trillions of years from now, in a world born from the ashes of our own. Environmental ethics, too, breaks free from its planetary confines. If the universe itself is our ultimate, shared environment, then our relationship with the cosmos shifts from one of exploration to one of stewardship. The principles of conservation and sustainability which we apply to our fragile biosphere extend to the cosmic scale. This means our handling of matter and energy, our potential for space-based industry, and even our long-term impact on the galaxy are not neutral acts. They are chapters in a story that may be read again in a future cycle, a civilization that learns to live in harmony with its cosmic home, that recycles resources with stellar efficiency and minimizes its entropy, is not just surviving. It is practicing for eternity, aligning its behavior with the deepest rhythms of reality. The development of consciousness itself becomes the universe's most significant project. In a cosmos that recycles itself, the emergence of self-aware beings capable of love, wonder, and ethical reasoning is not a random side effect. It could be a central feature of cosmic evolution. Every moral choice we make, every act of compassion, and every leap in understanding contributes to the maturation of this cosmic awareness. We are the universe awakening to itself, and the ethical quality of that awakening matters. If consciousness is a thread woven through the cycles, then fostering wisdom, empathy, and a reverence for life becomes our most profound duty. We are cultivating qualities that might one day inform the very foundation of a new reality. How does this perspective change the weight of a single act of kindness? It suggests that our deepest values may be the most enduring things we can contribute to the endless dance of creation. Take a slow, deep breath in and feel the gentle expansion within your chest. Now exhale fully, a soft release and contraction. This simple, automatic rhythm is your body's own intimate echo of the universe's grandest dance. Every inhale is a miniature Big Bang, a drawing in of energy and potential. Every exhale is a letting go, a necessary release that makes space for the next beginning. You are already living the cycle, breathing it moment by moment. Look at your own hands. The calcium that strengthens your bones was forged in the heart of a star that died billions of years ago. The iron carrying oxygen in your blood is a relic from a supernova's violent, creative blast. The very carbon that forms the foundation of your body was recycled through ancient oceans, soil, and countless generations of life that came before you. You are not just in the universe, you are a collection of its most ancient, repurposed materials, a living testament to cosmic recycling. Your daily life is a cascade of these rhythms. You wake with the sun, a period of expansion into the world, of activity and creation. As dusk falls, you naturally contract, retreating into rest and sleep, a time for repair and integration. This is not a disruption to your life, it is the essential pattern that sustains it, a personal echo of the cosmic cycle of activity and quiescence. Expand your awareness now to the world outside your window. Watch the steady, reliable turn of the seasons, where the vibrant explosion of spring gives way to the fruitful abundance of summer, then to the release of autumn, and the deep, quiet rest of winter, all preparing the ground for spring's return. Our planet itself is on a vast, yearly orbit, a cyclical journey around our star, and that star, our Sun, is midway through its own 10 billion-year life, a temporary beacon in a cycle of stellar birth and death that has been playing out across the galaxy for eons. Now, let this awareness expand to the grandest scale of all. Contemplate the entire cosmos not as a static void, but as a living, breathing entity in its own right. It expanded from a hot, dense beginning, blossomed into galaxies and stars, and will one day, according to the cyclic view, contract or transform, only to be born again in a new fire of creation. All of these cycles, from your single breath to the lifespan of a universe, are woven from the same fundamental pattern. How does this recognition change your sense of self? You are no longer a solitary, temporary spectator. You are a focal point where the universe becomes conscious of itself. Your brief, beautiful life is a single, conscious breath in the endless life of the cosmos. The anxieties of a single day, the struggles of a lifetime, are held within a context of unimaginable patience and perpetual renewal. You are not a drop in the ocean, you are the entire ocean, contained for a moment in a single, precious drop. We have traveled from the faint whispers in the cosmic microwave background to the silent, gravitational memory of black holes, piecing together a universe that operates on a rhythm of eternal return. This grand perspective suggests that cosmic death is not an ending, but a transformation, a necessary phase of quiet that precedes a new genesis. Our linear experience of time, from birth to death, may be just one small arc within an infinite, oscillating wave. Within this framework, our very existence takes on a new and profound significance. We are not temporary accidents in a void, but active participants in a cosmic process of learning and renewal. Carl Sagan's beautiful insight that we are a way for the cosmos to know itself resonates with staggering force here. Our consciousness, our capacity to look up at the stars and unravel these mysteries, could be the universe gradually waking up to its own cyclic, magnificent nature. The questions this journey raises are as vast as the cosmos itself. How does this vision of an endlessly recycling universe change your personal sense of meaning? Does the idea that every ending is a new beginning on a cosmic scale bring comfort, or does it challenge your deepest beliefs about reality? I invite you to share your reflections in the comments below, to explore how this concept of cosmic recycling resonates with your own understanding of existence. If this journey to the edge of knowledge and imagination has expanded your perspective, consider subscribing for more explorations into the profound